How does neuroplasticity shape neural correlates? Imagine your brain as a city that's constantly changing its roads and neighborhoods based on where people go and what they do. That's similar to what neuroplasticity does in your brain. It's the brain's ability to reorganize itself by forming new connections or changing existing ones. This process directly impacts neural correlates, which are the specific patterns of brain activity linked to different thoughts, feelings, or actions. When you learn something new or experience a change, your brain adjusts these patterns. Neuroplasticity mainly involves changes at the synapse level, which are the tiny gaps between neurons. When you practice a new skill, certain pathways get stronger because they're used more often. This is called synaptic strengthening. Conversely, pathways that aren't used may weaken or be pruned away. This reshaping of connections changes how your brain processes information and influences the neural correlates associated with those functions. In some parts of the brain, neuroplasticity can even lead to the creation of new neurons, a process called neurogenesis. This is especially true in areas like the hippocampus, which is involved in memory. The brain can also reorganize itself by shifting functions from damaged areas to healthy regions. For example, if one part of the brain is injured, other parts may take over its role, changing the neural activity patterns seen during specific tasks. Neuroplasticity also affects how different brain regions communicate. It can change neural oscillations, which are rhythmic patterns of activity, and the way networks of neurons synchronize. These changes influence the neural correlates observed during brain mapping and diagnostics. For instance, learning a new language can cause different or additional brain areas to activate during language processing, reflecting the brain's adaptation. This ability to change can be both good and bad. Adaptive plasticity helps recovery after injuries and improves skills through training. But sometimes, it can reinforce harmful patterns, like chronic pain or certain mental health issues. That's why understanding how neuroplasticity shapes neural correlates is key for developing neurotechnology tools. These tools can track brain changes, diagnose conditions by spotting altered patterns, or help guide brain enhancement methods like neurofeedback or brain stimulation. In essence, neuroplasticity is the force behind the brain's ability to learn, recover, and sometimes malfunction. It constantly rewires the neural correlates that underpin our mental functions, making the brain a flexible and ever-changing organ.